Hello! Today you join me once again in the development process for a project of mine I'm now calling the Jet Engine Project. In this video, I'm going to be pushing my little engine to its absolute limit with its current design. Let's get into it. But first, we have to get there. So let me explain what's going on. As we all know, the more air we can force into a combustion reaction, the more fuel we can burn, which ultimately extracts more energy in the same amount of time. In short terms, the more air, the more power. With my previous video, you saw Mark 1 of this jet engine. It wasn't much, just a little can with a propane line and a fan. This version uses an electric leaf blower to sort of turbocharge this can. That's all a jet engine really is, a turbocharger that can spin using its own exhaust. There's at least 100 times more air going through the system than before, if not more. The leaf blower is actually built a little like a jet engine already. It has a compressor-style blade in it that forces high-speed, high-compression air out of it. In this clip, I've propped up the leaf blower to push air into the intake side of the can. The way it's set up, air speeds through and around the fuel rail, which sort of atomizes the fuel and leads to a more efficient burn. I'll shut up for a little and let you watch a few seconds of this engine running. Apart from these nice videos, I have a slow motion video of this engine starting to run hot and catching my garage on fire. Again. I'll play that now and explain what's going on. Okay, so I start off by cracking open the propane line and lighting the propane with my torch. Then, as I flip the bottle to let liquid propane flow, I flip the switch for the leaf blower. Immediately you can see that the flame almost goes out, but catches itself and reignites the fuel. After a bit, the exhaust goes from a blue to a pale blue at the core. This suggests that the core of the exhaust flame is reaching around 2,000 degrees Celsius, which is about 3,700 degrees Fahrenheit. This is absolutely insane for a piece of junk I just made in my garage, and is super promising for later versions of this design. I've already started to design a compressor in Onshape, and I started 3D printing some parts for later use, after I figure out some design flaws. Switching from Blender, which is more catered towards art, to Onshape really helped to speed up the design and prototyping process. What would have taken me several revisions using Blender only took me a single try in Onshape to get the shape and fit just right. This saves an enormous amount of time and plastic filament, which is really expensive right now. My current problem right now is this shaft coupler thing in my design. This part connects the motor to the blades that make up the compressor. My problem is that I can't 3D print it because it has very fine threads built in, meaning that this is the very first part I have to fabricate from metal. Specifically, I'll be using a 10mm rod made of 6061 aluminum. These fancy numbers basically mean that it's the right material at the right size. As soon as I get it here, I can continue with officially making Mark 2 of this design, which should be the foundation I need to create a proper turbojet engine. Anyway, that's all for now. Thanks for watching. I can't believe it's already been like 3 months since the last video. I still suck at managing time and procrastinating. Hopefully I can get another video out in the next month, but you'll have to be patient with me. Anyway, thanks for your time, and Happy New Year.